Research and simulation analysis on the character of Walker Constellation network for global networking, real-time telemetry track and command. The results of ground telemetry track and command station are limited, and the visible arc section of satellite is short, which greatly limits the timeless of satellite on orbit operation control and information return, and affect of the full play of satellite efficiency. As a means of response, the relay satellite was born to meet the need of full arc telemetry and of key tests. In order to meet the requirement of real-time telemetry and command in global network, this paper designs constellation network simulation system, studies the transmission characters of ground telemetry and command data and autonomous telemetry and command data in typical constellation configuration, and carries out quantitative simulation analysis. It provides a reference for the optimization of network topology, node cache configuration, routing algorithm, and data generation strategy in system design. For this reason, it's inevitable tend to use the inter-satellite link to network the system set to provide telemetry and command service to the whole network satellite through the domestic satellite in the visible arc section, and to realize the global network telemetry and command application. Different from the simple communication service model of traditional ground or relay satellite, direct telemetry and control satellite is more difficult to analyze the service capacity, transmission capacity, delay character, and node cache of satellite network transmission. In the design of real-time global GT and C system, in order to facilitate the analysis of the load capacity, transmission delay, node cache setting capacity, and other design parameters of the network system, reasonable or above design items need to be analyzed and verified by simulation. The figure above shows the structure of constellation network communication simulation of software, mainly include several parts. Simulation input, it includes constellation model input model, transmission demand input model, route processing strategy model, link parameter input model, which used to set simulation related input parameter and policies. Pilot intervention assembly. Simulation pilot intervention model is mainly used to adjust simulation start time, end time, simulation step length, simulation process control, fault injection, and abnormal event injection. Model and data generation model. The model and data generation model generate the data and the models needed for simulation, including topology model, routing table model, data load model, link transmission model, and more, node routing process model. Based on track, visibly, chain building planning, routing planning, and other domain algorithm. Simulation engine model. The simulation engine model is a core part of the simulation system, which is responsible for model loading, running, timing, triggered event deduction, timing, triggered state transmission and update, simulation parameter statistics and display model. The simulation parameter statistics and display model is used to statistics and visualization of important information in the process of network simulation, which supports users to extract statistics and visualization of parameters such as cache queue depth, link load, node load, delay, forwarding hops, congestion act, of which node and link in the simulation model at each simulation time, and support parameter collection and user-defined statistics process functions. Software operating environment model. The software operating environment provides integration and operation environment of the above model. In this project, MATLAB is used to provide the software integration operation environment. In our study, the 24-star scale constellation network is used as the simulation research since the commonly used Walker Constellation 1,500 km altitude orbit and 60-degree tilt order are used. The number of the link between stars is no more than 3 to 4 per satellite, and the network topology map is generated by the strategy of ring chain establishing in orbit plane and dynamic chain establishing across orbit plane. Generally speaking, Walker Constellation is used in a global network system, which is characterized by circle orbit, unified distribution of multiple orbital planes, and even arrangement of satellites in the orbit plane, as shown in the figure above. In the aspect of communication demand as a network load, the telemetry and command data mining include real-time periodic satellite telemetry data, on-demand burst test instruction data, on-orbit maintenance data, and observation process task result data transmission. The original load data with large amount of data is generally not transmitted through the network, but through the data transmission link after using the local star cache. In the above scenarios, the influence of constellation configuration, link bandwidth, number of cross-orbit link, transmission requirement, data source characters on network performance is studied, which provides basic for the rationality, flexibility, and engineering optimization of constellation network design, which support constellation config optimization simulation. Network simulation provides the ability of constellation configuration optimization comparison. Taking 24 constellation design as an example, under the fixed link bandwidth situation, for the purpose of network transmission optimizing through the simulation data, analyze this and compare the advantage and disadvantage of 4 orbit plane multiply 6 satellites and 3 orbit plane multiplies 8 satellites to typically constellation configurations. Support link bandwidth verification. Because of the complexity of network topology, it's difficult to analyze and calculate by several metric means. Therefore, in the design of constellation system, it's necessary to verify the key parameter of the link. The matching of constellation combination requirement, communication load, and the correctness of link bundles designed by simulation. Support cross-orbit link optimization. Support analysis of supporting transmission demand satisfaction degree. Supporting time distribution analysis of data source. Different simulation sequences are constructed according to the network transmission factor, and various design factors are evaluated and optimized in simulation experience. Simulation analysis of the influence of the network topology on transmission performance is shown below. Simulation analysis of the impact of link bundles on the network capacity is shown below. The simulation of the analysis of the impact of cross-track link configuration is shown in the table 4. The simulation of the analysis of the influence of data transmission model is shown in the table below. And last, simulation analysis of influence of the data generation time distribution is shown in the figure 6 and figure 7. Conclusion: in constellation network simulation system, the Walker Constellation network model, network transmission model, routing and forwarding model, timing-driven simulation engineer, and simulation parameter selectors and display module are designed. The simulation system is built and the simulation sequence is run. Through the Walker Constellation network simulation system, simulation research is carried out, focused on the transmission calculation of ground TT and C data and autonomous TT and C data in the network, which provide reference for the network topology. Bandwidth capability configuration, node cache configuration, routing algorithms, and data generation strategy design, optimization, and network transmission capability analysis and visualization in the system design. Okay, thank you.